Welcome, everyone, to the Hydrogen Podcast. I'm your host, Paul Rodden, and today we have an exciting guest joining us. Dr. Eugene McKenna, the Senior Vice President of Hydrogen and Sustainable Technologies at Johnson Matthey. Dr. McKenna has been a leading figure in the hydrogen industry for years, and we're thrilled to have him on the show to share his insights. So, the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. Dr. McKenna, it's a pleasure to have you here. Before we dive into today's topics, could you tell our listeners a bit about your background and your journey on becoming a leader in hydrogen and sustainable technologies?
I will indeed, Paul, and it's great to be on the show. So I studied chemistry at university in Belfast, Northern Ireland during the Troubles era. It was always a subject that absolutely fascinated me. It struck me that the world around me, that was, both the natural world and the world that we make was literally constructed of chemicals. And chemistry seemed to me to be at the heart of our ability to mold that world for better or for worse. I was interested in for better, to bring positive change, health, and prosperity to more people around the world. So I joined a global energy company, energy and chemicals company, working in technology, and that took me on a journey around the world, living in around 6 different countries, often focused on new technology commercialization for a few decades. And then around 8 years ago, I had the chance to join Johnson Matthey. And what really attracted me to them was the chemical toolkit they already had at their disposal, aimed at existing fossil fuel powered world. And I was interested in how that toolkit could be modified and used to focus on the energy transition in general and low carbon hydrogen in particular. So I had the chance to lead in technology strategy and commercialization in those areas, and that was a great chance to get involved in this area.
So Johnson Matthey, it's a name that's well known in the field of sustainable solutions. But for those who might not be as familiar, can you give us a brief overview of Johnson Matthey's work in hydrogen and the company's broader vision for sustainable technologies?
It's sometimes not as well known as it should be, I think,
Mhm.
in the wider world, as it's B2B company.
Yeah.
But it's a long-established British company, and it started with a man who was interested in the esoteric chemistry of gold and platinum group metals. In fact, I think his first job was certifying the purity of the gold held by the Bank of England, which was clearly a useful skill. And his interest in chemistry and ability to supply platinum made him friends with the early pioneers in things like electrochemistry. So,
Mhm.
for example, he loaned platinum to Michael Faraday, who invented electrochemistry, and
Wow.
William Grove, who invented the hydrogen fuel cell. So we've been on a bit of a journey. In fact,
Yeah.
I'm talking to you here from my home, which is in Clapham in South London. And
Mhm.
it's a few hundred meters from the house where Henry Cavendish had his laboratory, and he actually
Wow.
discovered hydrogen there. So there's quite a tight connection with London and Johnson Matthey in the hydrogen world. So that kind of interest in platinum group metal chemistry has since in the last 200 years, it's taken us into a range of sustainable technology areas. So first of all, we invented the three-way catalytic converter, and it's actually 50 years old to this year, that invention.
Hmm.
And we supply
Wow.
about 40% of world demand. And that's with a real focus on cleaning the tailpipe emissions of internal combustion engines, but it's
Mhm.
local air pollutants like SOx and NOx.
Right.
And then that took us into process chemistry, where we design chemical processes and manufacture the catalysts that make them work. And that business has a particular strength in syngas chemistry. And that's what got me interested, because that's a key technology in the energy transition. And it gives us the ability to make low carbon hydrogen, ammonia, e-methanol, and SAF through Fischer-Tropsch chemistry. Then we have our hydrogen technology business, where we manufacture the catalysts, which of course are platinum group metal catalysts, membranes and catalyst coated membranes that are at the heart of PEM electrolyzers and fuel cells.
Mhm.
And all of these are supported by our original platinum group metals business, our platinum group metals business, which is it's the largest refiner and recycler of platinum group metals in the world, and it's critical to many of these sustainable technologies.
So, Eugene, Johnson Matthey has been heavily involved in the hydrogen space for years. Could you give us an overview of the current hydrogen infrastructure and how it's evolving globally and where the biggest gaps still lie?
Yeah. So I'm sure your listeners are familiar with the rainbow of hydrogen, but
Mhm.
I simultaneously like it and dislike it, but I'm gonna reference it a little bit here. So clearly the world, if I think about grey hydrogen to begin with, the world already has a well-established infrastructure for the
Right.
manufacture, distribution, storage, and use of hydrogen in applications such as chemicals manufacture and sulfur removal from petrol and diesel. It's
Mhm.
actually that allows those catalytic converters to work so well as the low levels of sulfur that's in the fuel. So industrial, it's really, sometimes I like to emphasize there's no mystery in this. Industrial gas companies have been adept at supplying this for years. But 99%, as I say, of this hydrogen, so-called grey hydrogen,
Mhm.
produced from methane and water in steam methane reformers, while just allowing the carbon dioxide to drift off into the atmosphere.
Mhm.
So clearly, in the long run, this is not the hydrogen that's going to help us with the energy transition.
Right.
But the good thing about it is that it does create use cases. We know
Mhm.
that where that hydrogen is made, or where it's used, there is a demand for hydrogen. Actually, as it turns out, Johnson Matthey is a leading supplier of the catalyst for that process. So existing infrastructure there, and we can piggyback on some of that infrastructure. And if it turned to blue hydrogen, that's
Mhm.
produced by a similar process to grey, except the CO2 is captured, which means and it's permanently stored, which means we need some more infrastructure.
Mhm.
So, however, that results in low carbon hydrogen. Our leading ATR GHR technology can make that hydrogen very low carbon, so we can capture more than 98% of the carbon
Yeah.
dioxide produced. These projects are now being developed at scale and the infrastructure to make them work. So, for example, two large scale projects in the north of England have just received £22 billion of funding from the British government
Yeah.
to make them happen, and they will be amongst the world's first really large scale low carbon hydrogen projects, and they'll
Mhm.
use JM technology. The key thing there is that solves a lot of problems is that they are going to be in industrial hubs. So
Right.
all of the infrastructure to connect up the production of the hydrogen with its transport, storage, and use, a lot of it's already in place, and the customers are already in the same industrial hub. One of the hubs already produces about 30% of the UK's industrial carbon dioxide emissions. So this is a clever strategy for making things work where you need the smallest amount of infrastructure possible. Start with the easiest problems.
Right.
So the HyNet project in the northwest of England will also export that low carbon hydrogen outside the hub through an existing pipeline network to take it to industries like glass making, which really can't
Mhm.
be done with electricity. It's natural gas or it's hydrogen. And clearly, we're interested in hydrogen.
Right.
Germany, incidentally, has just recently announced plans to expand its hydrogen pipeline network.
Mhm.
And as that pipeline network gets bigger, you can see that you can have large amounts of hydrogen produced and taken to ever more remote locations where the industry is. Green hydrogen, the one we also have an interest in, the kind of dynamics of where it's produced are likely to be different to blue hydrogen, where large
Right.
amounts of it can be made in one location and close to where it's used. So there's some more infrastructure issues there about putting it close to the renewable energy, also potentially putting it close to countries where the photons and the wind are plentiful and cheap,
Mhm.
which isn't necessarily in the same place that we need the hydrogen. So I'm thinking of Australia and Brazil.
Yeah.
They will have their own uses too. And then I think when we get into infrastructure, we're going to be looking at the whole infrastructure build out of either moving hydrogen or a carrier, like making it into ammonia or making it into methanol. And we're also going to have to think about potentially moving carbon dioxide about if we don't make blue hydrogen in the same location
Right.
where it's made. So I tend to think that, if I look at the world around us, I know you're in Houston there, so you'll see the
Mhm.
infrastructure of the energy of the fossil fuel industry is all around us. And
Right.
we're not surprised by that. We know it's transformed the world in the last century. Well, I think we're going to reuse as much of that as possible, but we shouldn't
Mhm.
be surprised that we need to build out a lot of infrastructure
Mhm.
in order to make a clean energy infrastructure work in the next decades, the next 30 years.
Yeah.
And I always remember that old quote you probably heard this rogue statistic knocking about that for several years in China, they were laying down more concrete per year than the United States did in the entire 20th century. So
Yeah.
things can accelerate, and I think that's the way things need to accelerate in hydrogen. But we shouldn't be afraid of that.
I couldn't agree more. But in your experience, what are the critical components required to establish a reliable hydrogen infrastructure that you were just talking about, particularly for heavy industry and transportation? How does Johnson Matthey contribute to that?
So I think on the transportation side, first of all, the devices that will enable hydrogen to be made to be used in transportation are fuel cells and clearly potentially hydrogen internal combustion engines. So
Right.
on the cell side, say we've been making those critical components for the last 20 years, and we're very focused on working with partners to increase the efficiency of hydrogen fuel cells so
Mhm.
that they can compete head to head with the diesel engine
Right.
and get down to cost parity. And the efficiency of the catalyst coated membranes and the reaction that's taking place on them will be key to reducing the cost of those in fuel cells
Mhm.
and making them more cost effective. But outside of that, the infrastructure build out that we know we need is hydrogen refueling stations. And
Mhm.
these hydrogen fuel cells, particularly good use cases, heavy duty vehicles that will move goods around, because that's very difficult to do with a very, very large battery. And
Right.
if I look at places like Europe, there are mandates for having refueling infrastructure every couple of 100 kilometers and having it in towns. I
Mhm.
think there's going to be a case for having mandates to insist that hydrogen refueling infrastructure goes in, because that gets us into our chicken and egg of
Right.
having you can't have a truck until somebody's cleared that they're going to refuel that truck.
Mhm.
But you can see network effects here. The first problems that we'll solve will be on routes where there are a certain number of hydrogen refueling stations can cope with a lot of trucks, and then
Mhm.
build out from there. So that getting the first infrastructure on the ground, I think, is very important. If I look at another area where I think the infrastructure problem needs to be solved, there's a lot of focus at the start in both the US and in Europe about making green hydrogen in
Yeah.
America, or making blue hydrogen in America, making it in Europe. But it's clear that there's going to have to be transport of clean hydrogen
Mhm.
around the world. So that gives us all sorts of opportunities for thinking about what the best way is to do that. So
Right.
you can move hydrogen as liquid hydrogen, but that's got to be very cold, and
Mhm.
the ships don't yet exist. Well, there's some of the first ships are coming along, but that's not a well-known technology.
Right.
That's got to be very, very cold. But turning it into ammonia,
Mhm.
we do know how to move ammonia around. There are ships that move already a lot of ammonia about. Ammonia then will need to be cracked back into hydrogen
Mhm.
whenever it comes from a low cost production location to a use location. So all of that infrastructure people will need to think about the making the hydrogen, turning it into ammonia or methanol, the ships that will move it about, and the cracking of it back into hydrogen at the destination. I think of some of the countries about in Europe and the United States, I'd be thinking about a competition between them for who can get that ammonia cracking infrastructure in, so that
Yeah.
that's where the value added activity takes place. It should be a People should be competing for where this
Agreed.
value added activity is gonna happen.
Absolutely.
And Johnson Matthey's clearly involved in both the
Mhm.
technology for making the ammonia, making that as cheaply as possible. We've done that at world scale. And also we have a commercial scale ammonia cracking technology, as well as being interested in the other carriers like methanol. So we're already involved in making manufactured e-methanol, for example.
Let's talk then a little bit about the market demand for hydrogen. How do you see demand developing in the US versus Europe? And are there significant differences in terms of how these markets are approaching the hydrogen economy?
So they absolutely are. I'm traveling about the US and Europe and more widely in the world. That there are waves of optimism and
Mhm.
pessimism, and typically, and looking over your shoulder about the other guy's regulatory environment and thinking
Mhm.
it's better. And when the Inflation Reduction Act came along, there was a kind of a wave of depression across the rest of the world, that it was outspending everybody else, and that was gonna, all industry was going to move there.
Yeah.
And indeed it was generous and appeared simple at the start, and optimism was all about how much hydrogen was going to be produced in the US.
Mhm.
And then, as ever in any environment where you're dependent on regulations, that failure to dot the I's and cross the T's on
Right.
exactly how to get your hands on the cash at the end of the day. I saw somebody describe it recently as that they could see there was a piggyback full of coins, but no matter how much they rattled it, they couldn't work out how to get the money out of the piggyback
Yeah.
bank. So, but by and large, in America, there's a focus on incentivizing the production of hydrogen and reducing its cost, and then a hope that normal market dynamics will result in demand for the product. That clearly hasn't quite come through yet.
Right.
Europe, on the other hand, has had a more balanced approach to both the incentivization of the production and the offtake. In particular, if I look at hydrogen production for industrial uses, then there's now actually a mandate that 42% of all hydrogen that is used in industrial processes by 2030 and 60% by 2035 must be effectively green hydrogen.
Mm-hmm.
There's lots of rules and regulations about how that might happen. So quite a different and balanced approach. Once again, looks very good. And indeed, lots of projects have reached FID in Europe. And I would have said at that stage, the momentum of enthusiasm moved, even
Yeah.
amongst American manufacturers, moved from the United States to Europe, thinking, the folks over there are actually getting projects FID'd and off the ground, but not yet quick enough for at the speed that we wanted to happen. So I think all of this shows the difficulty that you have with planned economy that we're having to work
Right.
with at the start. We all eagerly await when it gets to the point where normal market dynamics can unleash some more animal spirits and get investment flowing in without people needing to think too hard about the regulatory environment. But we're not there yet in either
Yeah.
the United States or Europe, where things are still complicated. And I often see a desire, and if I could perhaps contrast with China now.
Mm-hmm.
So if I look at Europe and North America to some extent, there's a huge desire that every molecule of hydrogen produced be really clean
Mm-hmm.
and pure with very low carbon and a real trail of evidence that it's low carbon and no corners cut, and a harder environment, for example, than there is for trading in renewable electricity, where you can have power purchase agreements. So
Mm-hmm.
moving molecules is being treated differently to the moving of electrons around.
Right.
And if I look at China, what they've done there is they're determined that they're going to have a hydrogen economy.
Mm-hmm.
So there's a large amount of hydrogen being produced. There's a large amount of renewable energy being produced, and they're really focusing on the use cases. So the majority of hydrogen fuel cell vehicles in the world that are on the road today are in China, and lots of the hydrogen that's fueling them is not clean hydrogen.
Right.
So they have completely separated in their minds the idea of the use cases for hydrogen and the production of hydrogen, with the idea that whenever they've got driven down costs and advanced the technology for the use cases in both industry and in transport, then at a later stage they can join up the clean hydrogen with the hydrogen use cases.
Yep.
And so that would be my concern would be that we've seen this in other technologies, and that it sounds like quite a good idea. But just at the moment, the approach being taken in the West is largely get the very, very clean hydrogen first and only allow the very clean hydrogen into use cases. And I fear that might slow us down a bit.
Yeah. Agreed. And Johnson Matthey has a long history of innovation. How is your team positioning the company to cater to emerging market demands for clean hydrogen in both industrial and energy sectors?
So you're quite right, where we are heavily investing in the technology because we've got quite different situations with blue hydrogen and with green hydrogen. So our low carbon hydrogen technology is quite a mature technology. So we've had similar types of technology deployed in methanol manufacture for many years. So we know and are completely confident about the manufacture of design of blue hydrogen plants at world scale. The thing that will drive down the cost of blue hydrogen will be making these plants and replicating it and getting better at making the plants and standardizing the design and the components that go into blue hydrogen moving forward, but starting with quite a familiar, mature technology. Things are very different on the green hydrogen side, where we completely anticipate that there's going to be substantial moves forward in technology. So the amount of hydrogen that you can get out of a square meter of catalyst coated membrane, we anticipate the energy density will go up, and that we'd be able to put in much more electricity into a square meter of membrane and get far more hydrogen out of it with time, using far less platinum group metal.
Yeah.
And so there's both a technology innovation that will drive up efficiency and down cost, and there's also going to be and efficiency that's driven by industrialization. So getting used to manufacturing these things. And I absolutely remember just a few years ago seeing electrolyzers being made in factories by folks with spanners who are tightening up every single cell in a 400 cell stack and connecting all of the pipes and connecting all of the electricity cables. And now
Yeah.
I'm seeing those done in factories where there's nobody to be seen, and robots are building these stacks, and they're building them with great precision. So, um, from our part, we are making sure that we partner with the right people, because our philosophy is our sustainable source of competitive advantage is our chemistry and catalyst knowledge. So
Hmm.
we're focusing on the bits of the value chain in green hydrogen which play to those strengths, and making the catalyst and the catalyst coated membranes and making that bit better. And then we're working with partners who are very good at making the electrolyzers and very good at industrializing the manufacture of the electrolyzers. And then those two things can work in synergy. Because if you fix the design before you ask for a catalyst coated membrane,
Hmm.
that's not the best option. Ideally, they get made together. And we talk about what we can do better and what's difficult, what's easier, what's expensive, what's cheap in a catalyst coated membrane. And when you get that dialogue going with manufacturers of the electrolyzer, suddenly go, well, I didn't have to make the electrolyzer that way. And if you tell me it'd be more efficient to make it the other way, we can change that design.
Yeah.
And I think the thing that's advantageous for all of those electrolyzer manufacturers is that when we make it scale, we're making it a scale bigger than any of those individual electrolyzer manufacturers could make. So they get the benefit of an economy of scale that they wouldn't get from doing everything in-house, as well as trying to work out how to be specialists in
Hmm.
chemicals and chemistry, as well as being good at the mechanical engineering side of things. So I think partnerships are really, really important here. On
Yeah.
the blue hydrogen side of things, there's a great advantage from our first projects at making partners. And it's not just on the technology side, it's on the commercial side of things. So we've worked out how to do the contracts, how to deal with the risks, how to apportion the risks, how to do things once well and learn from it and then replicate it again somewhere else. So I think there's some quite tight partnerships turning up in blue hydrogen that will enable the next projects to accelerate and be very cost efficient.
Then looking ahead, are there specific market dynamics in Europe or the US that make one region more attractive for investment in hydrogen technologies compared to the other?
So I think that both of these areas have wonderful building blocks in
Mm.
place to kick off the hydrogen economy, with some gaps in the legislation. And those gaps at the moment are gumming up the works and
Yeah.
slowing things down. So people have stepped up to the plate and they've been ready to go with projects, and they've stepped back from the edge. But everything's in place. I say, looking at the number of projects that there are out there, with an increase in the number of projects that are reaching FID, but
Hmm.
still a large number of projects that are pre-FID.
Yeah.
Very small number of projects that have actually been cancelled. So we're pump primed with a lot of projects
Right.
that I think could be unleashed if the last few I's are dotted and T's are crossed on the next phases of the regulation. So there's particular legislation in the US around 45V is the
Right.
technical term, and whenever we get past I believe you have a few events coming up in the near future in the United States that may occur on the other side of that demonstration of democracy that's coming up in
Right.
the US. Likewise, in Europe, there've been successful hydrogen auctions, and more hydrogen auctions are planned. But there's consultations going on about how those rules could be tweaked to unleash those projects hitting the ground at a much faster pace. So I'm pretty confident that most of the things that this industry is ready to accelerate, and
Hmm.
most of the things that are required to accelerate it, are regulatory and political rather than technological
Yeah.
or supply chain constrained.
Speaking of supply chains, the hydrogen industry is still maturing and supply chain resilience is becoming a major focus. What are some of the most pressing supply chain challenges you've encountered in the hydrogen industry, and how is Johnson Matthey working to overcome them?
So clearly, whenever you've a hugely expanding new industry, you discover supply chain constraints everywhere you look. And as the battery materials industry has discovered, Johnson Matthey's very interested in some of the critical raw materials essential for the energy transition and for the production of clean hydrogen, in particular the platinum group metals.
Mm.
So for PEM electrolyzers and PEM electrolyzers of the various technologies that are involved are the ideal technology for direct connection to intermittent renewables. So we think they will play a part in the energy transition and the production of hydrogen because of that particular facet of the technology that you can connect it to intermittent renewables and because of its small footprint that's in there. But it requires iridium, and
Mhm.
iridium is very interesting. It's very interesting metal. I'm always keen to talk about because I know there are people who are put off the whole technology by the idea that iridium is required now. So it's produced in very small quantities. It's 7 tons a year is the current manufacture of
Mm.
iridium, which is about a 60 centimeter cube globally produced because it's the second densest metal that's out there. Thinking about 30 centimeter cube of that going into this application will be sufficient to supply this industry. But
Wow.
what's crucial in there is that every single one of those catalyst coated membranes that goes into PEM electrolyzers
Mhm.
is recycled and that the iridium is recovered from it. That's the way in which, so if we think about this industry maturing, we go from having 7 tons of iridium available each year with a portion of it going on to this application, as long as we don't lose the portion that goes on to this application. When the
Yeah.
CCNs are changed every 8 years, eventually there will be more iridium on coming out of electrolyzers for recycling than there is coming out of the mines.
Yeah.
So, and I say Johnson Matthey runs the already recycles iridium. We've now developed a process specifically to recycle catalyst coated membranes that will,
Wow.
and it's a cold process, so we don't have to burn anything.
Mm.
So we can recover both the membrane and the ionomer in the membrane, which is important because you don't want to let that escape. And it can recover the platinum group metals in a cold process. So that's
Wow.
95% less carbon footprint in those recycled products than there is in the first one. So I think that's an example of where we're playing to our strengths
Yeah.
to solve one of those supply chain issues that can concern people. I mean, I think the other thing about platinum group metals that is really different to some of the other critical raw materials that we come across in the energy transition is
Hmm.
that the world outside China, the world there's kind of a Chinese supply chain for platinum group metals and a world outside China with
Right.
well developed recycling and supply network that works perfectly well now. And we don't actually require any more platinum group metals in order to make hydrogen and produce fuel cells. We just need to manage the platinum group metals and supply that we have at the moment. And it's not coming from Russia. It's coming from South Africa and Southern Europe. So
Right.
mature supply chains that as long as we recycle, we've got that under control.
And we just touched on this a little bit, but one of the critical issues often discussed is the availability of critical materials needed for hydrogen technologies. How do you see this challenge evolving? And what are the strategic measures that Johnson Matthey has in place to mitigate material shortages?
So I think clearly we play to our strengths where we focus on the platinum group metals
Hmm.
side of things. We also think very carefully about the criticality of raw materials going into all of our designs. So we're thinking recycling from the start and we're thinking sustainability from the start in our manufacturing processes. We have a plan in place for the sustainability of our own manufacturing processes going forward, both from the perspective of carbon footprint
Hmm.
and making sure we don't bump into any critical raw materials and thinking all of the UN sustainability goals in terms of the sourcing of those things. I think that's in terms of our own manufacturing, thinking about our own manufacturing. What we do think, however, is I'm keen to point out to people that often are surprised by the fact that looking at the cleanest blue hydrogen and the cleanest green hydrogen that are about at the moment, they come out at
Hmm.
similar levels of carbon intensity. And the reason for that is that the green hydrogen involves the embedded carbon in all of the infrastructure right back to the renewable energy. So if you're doing that in the UK, you've got offshore wind with large amounts of concrete and steel going into the offshore wind,
Hmm.
followed by copper that's being mined from large amounts of crushed rock in
Right.
South America, probably brought to shore and then the electrolyzers and the infrastructure to move the electricity around and the electrolyzers themselves. So one thing that we like to see as we go forward is that with the adoption of hydrogen in the manufacturing processes, for example, in mines using hydrogen powered
Right.
vehicles in the mines, As I said, at the moment, it's 50 times higher carbon content to make an ounce of iridium from a mine than from recycling. But as the mines become cleaner, as they use more electricity and renewable electricity, and as they use more green steel, and so there's a positive cycle involved here too. So steel, for example, is steel has a bigger carbon footprint than all transport combined. And we have a tendency, and we look around us and we see cars and we see
Yeah.
airplanes, and we're very focused on that and tend to ignore the steel that goes into them and the steel that's in the world around us. And that's as big an emitter of carbon dioxide. The key to making that steel green is lots of green hydrogen, lots of clean hydrogen and low carbon hydrogen. And that's when we
Right.
start to get a virtuous cycle of where the critical raw materials can be produced in a sustainable way. But there's no two ways about it. We're going to need a larger amount of critical raw materials
Mhm.
through the energy transition than we have taken out of the ground, the history of industry and mankind so far. So I think if you don't like mining, you're not going to do an energy transition.
Right.
But it can be done responsibly and it can
Mhm.
be done with a low carbon footprint. So I think you can see the things. There's a real advantage in accelerating because so getting hydrogen into steel, getting hydrogen
Mhm.
into mining, both have the potential to make the process of greening the world a much greener process.
So transitioning from there and moving on to another really exciting area, sustainable aviation fuels.
Yeah.
Can you talk about the role hydrogen plays in enabling sustainable aviation and what Johnson Matthey is doing in that area?
So this is an area that is indeed dear to my heart because kerosene is a
Hmm.
wonderful invention that, there's what a molecule invented for moving people around the world. And we've all benefited
Yeah.
from in the Western world, in the developed world, from seeing the world and being educated by it. I'd like to think of aviation keeping people close together on into the future too, but we got to do it in a way that doesn't destroy the environment. So there's a few ways of going about this. Sustainable aviation fuel is basically non-fossil fuel based aviation fuel.
Hmm.
Most of the sustainable aviation fuel today is biosourced, so it's either used cooking oil
Right.
or it could come from other biosources. But effectively, you've got the molecular structure already in the oil. You're taking the bio oil and you're taking the oxygen out of it to make a molecule that's not dissimilar to that kerosene in the first place.
Hmm.
The trouble is that there's a limited amount of used cooking oil in the world, and there's
Yeah.
also a limited amount of space that we can allocate to oil-based crops because
Hmm.
they'll end up interfering with the food chain and also with biodiversity. It may not be the most efficient way of doing this. So the technology that we've got into in Johnson Matthey is Fischer-Tropsch.
Hmm.
And I mean, we go back in Fischer-Tropsch a long time. We have the catalyst plants in the group that make Fischer-Tropsch catalyst that in Germany and the UK that made Fischer-Tropsch aviation fuel during the Second World War for both sides. So both those catalyst plants are in the Johnson Matthey group now. But that's old Fischer-Tropsch technology. The new technology that we've come up with that we jointly developed with BP is a scalable Fischer-Tropsch technology that happens in a small reaction vessel, which we call a can. We
Hmm.
stack many of these on top of each other, and its beauty is that we get the same capital efficiency out of a stack of 70 of these cans as traditional Fischer-Tropsch processes
Wow.
do out of $20 billion plants. So if you want traditional Fischer-Tropsch, you need to really build a plant on top of an enormous gas field. But with our Fischer-Tropsch, you can look for smaller sources of feedstock. So
Hmm.
some of the first feedstocks involved have been biomass. So municipal solid waste, or it could be waste from producing sugar.
Yeah.
Any biomass will do that, which gets gasified into syngas. And I mentioned we're very keen on syngas. From that
Yeah.
syngas, then we go through Fischer-Tropsch through this process, and we can go to wax, which we can then cut into sustainable aviation fuel. An interesting twist on that technology is that with syngas, you can either start with biomass that has the energy and the chemicals already in there,
Hmm.
or you can go all the way down the energy waterfall and you could start with water
Hmm.
and carbon dioxide. You turn the water with renewable electricity into hydrogen and oxygen. Then you've got your energy and the components of syngas. You've got your hydrogen and your carbon dioxide, and you can turn that directly into kerosene and renewable aviation fuel. And that disconnects you completely from needing biomass and the amount of biomass that there is in the world. And the first plants are there's a plant being under development at the moment by Repsol and Saudi Aramco in Spain at the moment to just take renewable hydrogen and carbon dioxide through reverse water gas shift to make syngas, to make carbon monoxide and hydrogen. And
Hmm.
that is going to be turned into sustainable aviation fuel. So I think then with that, as the scale up of that process will drive down the cost of the process. And then it's really just a question of how cheap the renewable energy can get in order to make, you can have as much renewable Fischer-Tropsch sustainable aviation fuel then as you have renewable sources of electricity.
There's been a lot of conversation about green hydrogen as a feedstock for synthetic aviation fuels. What do you think are the key barriers to scaling that technology, and how is Johnson Matthey addressing them?
So I think hydrogen into that process. The first
Mhm.
plants are being built. I think what we need to drive that forward, and so within sustainable aviation fuel, the issue that's always cited is cost. Now, with the first generations of sustainable aviation fuel, there also isn't enough of it.
Yeah.
It's also come to a chemical point. Most of the sources of sustainable aviation fuel produce paraffinic
Hmm.
aviation fuel. So it's aliphatic, straight chains, like kerosene. And
Right.
actually, kerosene from fossil fuels contains about 20% aromatics.
Hmm.
And the aromatics are key to the functioning of the sustainable aviation fuel. They lubricate the engine
Right.
while the fuel is being burnt. And very few of the processes make this, but we've also developed a process in Johnson Matthey, along with Virent or with Marathon at the moment, to turn sugars or ethanol directly into the aromatics that can be
Wow.
used in that process. So then you can get to 100% sustainable aviation fuel because you can make your aromatic component as well. And the first flight that flew from London to New York with 100% sustainable aviation fuel, a Virgin flight, used that 20% aromatic component to
Oh,
enable them
wow.
to go up to 100% sustainable aviation fuel. But in terms of driving the cost down further, the real issues are the same that we have for hydrogen in general. And that's we need to scale up the technology and have mass adoption of the technology. And then we need mass renewable electricity so that the
Mhm.
cost of that renewable electricity goes down as well. And we can see how the dynamics of that are forming. One thing I would say about aviation fuel is people often say people won't pay a dollar extra for a liter of sustainable aviation fuel
Mhm.
unless they're forced to.
Right.
I really don't think this is a cost problem because crude oil goes from, I've seen crude oil from 120, $130 a barrel down to 20, $30 a barrel the last time there was a dip. And people keep flying. So
Right.
people pay what they got to pay. The key thing here is competition. An airline can't buy more expensive kerosene if their competitors can buy cheaper kerosene. So
Right.
that's why we need regulation. I do not think that 10 or 20% more expensive sustainable aviation fuel would result in a reduction in the amount of flying that was going on, as long as people had to buy the
Right.
sustainable aviation fuel that was 10 or 20% more expensive. So therefore, mandates are really important, mandating the amount of sustainable aviation fuel
Hmm.
that must be used. I
Hmm.
think that's what will keep a level playing field. And naturally, people don't like some extra cost coming into the system. The more
Yeah.
we deploy, the lower that cost will give. But I do think the market will stand the additional cost as it's demonstrated every time the price of oil goes up.
And speaking of that regulatory landscape, what policies would you like to see to help accelerate the adoption of sustainable aviation fuels? And how are you engaging with policymakers to support those goals?
So we like to talk. I mean, clearly in this regulated environment,
Hmm.
our objective is to help the world get to net zero as quickly as possible. And we've got expertise. So we talk to government and the Commission in Europe and in the UK where we're based. And through our US operation, we talk in the US about what we think would help the industry to go quicker and what
Hmm.
effects we think regulations would have and when we think regulations are a particular problem. On the SAF front, I do think it's mandates that would help and bringing forward mandates for the minimum percentage of sustainable aviation fuel that needs to be in fuel and the cranking up of that number as we go forward. Once again, I think this is an opportunity for disruption in the airline business because good locations for sustainable aviation fuel will be good locations for hubs for flying in and out of. So I think if people in various jurisdictions were thinking ahead, they would be thinking not just in terms of the cost, which, clearly we have to manage cost in these times and make things as cheap as possible, but doing this in a more competitive way than the competition may bring economic benefit to your region. So the more innovative you are in terms of regulation, the easier it is to comply with, and the more it incentivizes people to use that sustainable aviation fuel, potentially brings the benefits of industry and economic activity moving in the direction of your jurisdiction.
So before we wrap up, are there any final thoughts you have that you'd like to share? Perhaps something that excites you most about the role that Johnson Matthey will play in the energy transition?
I think of strategy and tactics. And so in the day to day, there are bumps along the road that we can see as we try to get projects to FID, as we step up to the plate and make investments, and then perhaps the demand isn't evolving at the same rate that we'd hoped, and regulations don't come at the same time. I am very excited by the fact that I know there is no route to net zero without hydrogen. There is no route to decarbonizing those hard to abate areas in industry without hydrogen. So I know hydrogen is going to come, and it's going to come at scale. I don't think it's going to come in a smooth way. There are bottlenecks that are going to be removed, and when they're removed, things will move forward quickly again, especially when I see the number of turnkey ready projects that there are. I think if we get that kind of magic dust and sprinkle it in the right place and get the right regulation, we'll see this pick up pace, and it's primed to pick up pace again. Yeah. So hydrogen's got to come. It's just a question of how much of the carbon budget we burn before we get the hydrogen coming quickly enough.
Yeah.
And I like to see through to the other side of that, where the built environment we have with us, with more and more people in the developing world coming out of poverty, with people across the developed world having the benefit of better healthcare and cleaner environments, it's all there for us, and hydrogen is necessary in order for it to make that happen.
I couldn't agree more. 100%. Eugene, thank you so much for joining us. It's been incredibly insightful for this discussion.
Well, thank you very much, Paul. Really good to talk to you.
And so to our listeners, thank you for tuning into the Hydrogen Podcast. If you'd like to learn more about Johnson Matthey and their work in hydrogen and sustainable technologies, be sure to check out their website at matthey.com to stay updated on their latest innovations. Thank you for listening, and take care. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.